Hey, hi everyone. Good evening. I hope I'm audible and visible. So I see already almost 30 people have joined. So let's start. So today, so in the last class, which was around 2 weeks back, so we had looked at basics of linked lists. We had looked at linked list as a data structure, and then we had tried to solve few problems on top of that, right? We had also discussed a standard algorithm of linked list in terms of loop finding. We had looked at how we can use a very popular algorithm for figuring out whether a loop exists in a list, and then extending the problem to figure out where in the list the loop exists, right? So this is what we had looked at in the previous class. Today we'll be looking at few problems which are of a similar type, a similar complexity, not similar type, but they can be solved in they can be solved in a similar way. Okay, and I'll not, so it's not very data structure specific, but these are types of problems like which are often asked in multiple programming contests, multiple interviews, where we talk about manipulation in strings. Okay, so some of the problems for many of you who have solved the problems, the first problem might seem very easy, but the later problems that we'll discuss today will build on top of the first problem and we'll try to solve it. Okay, so let's go into that. Let me share a Google Doc that we can use. We can use the OneNote itself actually. Yeah, so I'm just sharing the OneNote. So let me know when you can see the screen. So one of you can confirm quickly if you can see the screen or not. Okay, visible, awesome. So let's talk about the very simple problem called the matching parentheses problem. So where we are given a string which has three types of parentheses, okay, and we have to figure out whether the string is valid or not, right? So let's try to solve that problem. So basically we are given a string and we want to see, so I'll just write it down here. So we are given a string str which has say parentheses like this, right? It has all the six characters, the six possible parentheses, right? So it has all these six characters, any combination of these six characters, and you have to find whether it is valid or not, right? So you have to find whether it is valid or not, right? So what does valid mean? Valid means that the number of opening and closing brackets has to be same of each type, right? So the number of brackets uh, of each type have to be same, right? And the other thing is the order in which they have opened and the order in which they have closed, they have to be in reverse order such that the mapping, such that the validity of the string remains correct. So the order of opening should be equal to the reverse order of the close, kind of, right? Or it should be a mirror image, in reverse basically. Okay, so for example, if I take this string is valid, right? But if I have this string or this string or this string, then these are all invalid, right? So this is the problem statement. So you have to figure out, given a string and which will have only these set of characters, these 6 characters, this opening and closing parenthesis, you have to figure out whether the string is valid or not. So how will you solve the problem? So this is a very standard problem that okay, I'll give you 5 minutes time to think about it a bit, and if any of you have seen the problem before or can come up with a solution, do put it in the chat for now, then we'll discuss. So how can we solve the problem? Okay, so I have got one answer, 2 answers. Yeah, so okay, 3. So more or less, I think many of you know how to solve the problem. I'll give 2 more minutes if anyone is genuinely thinking and seeing the problem for the first time. So how can you come up with a solution around it? Yeah, so I think so we can, okay, so many of you have put the solution up in chat. So so this is a very standard problem that we try to solve, right? So let's take a string itself, and so let's have the string something like this. And what we need to do, essentially, we are saying that whenever we are opening it, in the reverse order, we should be closing it, right? So the most, and obviously we should be checking it outside in. So we'll be going from here, but at this point of time, if I find this, so I should be checking with the last opening bracket only, right? And not before that. So, or the other thing is, say if I have something like this one, I should be checking with this one, not this one, right? If I have to check this bracket marked as an asterisk, I should be checking it with this one, the other one marked as an asterisk, not with the third one which is marked as a dot, right? So we should be doing the thing inside out. So we should be validating things, and whenever the part is validated, we can remove that, and the remaining part now needs to be worked on, right? So if that needs to be done, then we can directly use a stack data structure. So we can have something like a stack here, and we will just be processing this thing. So whenever there is an opening bracket, so whenever there is an opening bracket, so we have defined initially, okay, these are my set of opening brackets, these is character literals, and these are my set of closing brackets. So whenever I get an opening bracket, I push in the stack, right? And whenever I get a closing bracket, I pop from the stack, but I check whether the last one that I pushed is a complement of that. So the complements also have to store in the map, right? So when I get the closing one, that is this one, the fourth one now, I check with this, and I see that these two are not complements, so I return false, right? On the other hand, if I had this example, so initially I pass this, then I pass this, and then I get a closing bracket. I check whether these two are complements on the top. Yes, these two are complements, so I pop it out, right? This becomes empty, and then again I get an opening bracket, so I pass it the opening parenthesis, and then I get a closing bracket which is again a complement, so I check with the top, again a complement, so I pop this one again. Right now I am left with only the curly braces, right? And then I see in the string also it has the curly braces, which is a complement, so I check these two and I remove this. Okay, so at the end I check whether the stack is empty or not. So if the stack is empty, I know that the string is valid. If the stack is not empty, I know that the string is not valid, right? There is something that was there initially that did not work. Okay, so this is like a very simple solution that we can use for solving this problem. The time and space complexity for this problem, in the worst case, the stack, so what will be the stack size in the worst case? Anyone? Say if the string length is n, so what will be the space complexity?
S by 2.
So if the string length is n, what will be the space complexity? Yes, someone mentioned
S by 2, I think.
why will it be or n by 2? Why will it be n by 2?
Sir, if a bracket opens, it must be closed.
Not necessarily, right? It might not be closed also. So we are the whole problem is that we have to return true or false.
Then worst case will be n, I think, sir.
The worst will be n itself when all the when we'll have a string something like this, and which will obviously be false, but in that case we'll be pushing everything into the stack, right? So the worst will be n only. Even if it was n by 2, then still the complexity would have been order of n, because order of n by 2 is always will be equal to order of n only in the big O notation, right? What will be the time complexity for this simple algorithm? Time complexity will also be equal to order of n, right?
Sir,
Because
same.
we are making one pass through the string. We are not making two passes over the string, so that will also be order of n, right? So this is a simple problem to solve. So any questions in this problem with step? Any questions? So clear it up now itself so that the other questions we can solve effectively. Anyone? Questions, concerns, doubts? No? So I'm not writing the code for this. Everyone is fine with that? Everyone can write the code for this, the logic that we discussed? Anyone needs the code? Let me know. I'll put it in a Google Doc somewhere and share it out. Okay. No questions. I don't see anything in chat, so let's move forward. So now let's take a look at a bit more interesting problem. Okay, so now let's say we have a string with now forget about this solution. Okay, so this problem has nothing to do with the next one, so it's a completely separate problem, completely different way of solving it. Try to think independently. I club similar problems together, but the solutions are not similar. Okay, so we have a string. Again, we are given a string, right? So of the string now has only the small first brackets. So the opening first bracket and the closing first bracket. Okay, so opening and closing parentheses, not the other two types, only one type. Okay, and along with that it has lowercase characters. Right, lowercase characters, so A to Z. So they have A to Z. Okay, so your task is to remove the minimum number of parentheses in any positions so that the resulting string is valid. Okay, so remove minimum number of parentheses. It can be open, it can be closed, right? Such that the remaining string is valid. Okay, so you have to remove minimum number of parentheses such that the remaining string is valid. Okay, so I'll put an example for now. So if your input is something like this is my input 1, say it is something like this, A closing bracket B C D, right? And then your output should be, you have to remove the minimum number of parentheses to make the string valid. So you have to return the valid string. So your output should be this. Okay, or if your input was say D, then what will be the output, anyone? What will I remove to make it valid?
Nothing, sir.
Nothing,
Sir,
because
this
is a valid string ideally. So my output will be the same string. Okay. So now this is a problem similar to the previous one, solution not similar to the previous one. Think about how you can solve this problem. Okay, so you have to remove the minimum number of parentheses, you have to make the string valid, and you have to return the valid string. Modification of the problem can be how many parentheses you want to remove, right? That is also a modification. You can derive it directly from here. So take 5 minutes time. I'll give you time to think about the solution. Anyone has any hunch, any questions or anything to discuss, you can unmute and we can discuss. Okay, I've got one approach. I'll wait for 5 more minutes, then we'll wait for 2 more minutes. After that, Dhruti, you think of the approach a bit more, then we can discuss. Okay. Anyone else thinking of an approach how we can solve it? Any initial hunch? Or can we use any learnings from the previous problem itself to solve this one? So note that, okay, two people, I think, okay, two people have reached out with the counting the closing brackets or counting the number of opening and closing. So if you just maintain the counts, it's a bit difficult because you have to return the final complete string, right? So having just the counts obviously won't solve the problem. So yeah, any one of you want to unmute and discuss your approach? Anyone who have mentioned Dhruti, Anand, I'm just scrolling up. Mirza, either any one of you, if you want to unmute and discuss, we can do that.
Sir, if we encounter a closing brace in the starting, then we'll just remove it. And
Okay.
after that, we'll just keep on repeating the previous problem where we check the validity of the parenthesis.
Okay, but say if your string is something like this, then this is not valid, obviously, right? And you have to
Sir,
remove
at the
these
end,
three things to make it valid. Yeah. So how do
sir,
you
we will
handle
take,
these cases? Sorry,
sir,
go
we
ahead.
will take a, sir, we will take a counter that will count the number of opening braces first, and at when it encounters a closing brace, it will decrement itself.
Okay.
At the end, it should be equal to 0.
It should be, it won't be equal to 0, right? Because like in this case, it will be 4 minus 1, 3. So it should be equal to 0 ideally if the string was valid, but the string is not valid, not necessarily valid, right? We have to make it valid.
Sir, if something is remaining in the stack, then we can just remove the remaining things one by one from the given string.
So tell me, how will you process it? So let's say this string is there, AB, 4 open brackets, and D. So initially, what will you keep in the stack?
The 4 opening braces, sir.
The 4 opening
All the
braces
four
going.
When closing is encountered, then one will be popped.
Right.
And then when our counter is now 0 and the string is empty, sir.
Counter
Counter is
is
3,
now
sorry.
0.
3, sir, sorry. Counter
Okay,
is 3
counter
and the
is now
string is
3.
empty.
Huh?
Then whatever remains in the stack will be equal to counter, I think, sir.
Right.
We could store
Then
the character along with their position.
Okay, so you can store the positions.
Then whatever are remaining at the end of the string, we have to, we can just remove that, go to that position and remove those.
Okay, so you are saying that you want to just store the positions, and then what you mentioned, we'll go to the string and
Like the previous problem where we were only putting the character, we
hmm,
will put the character along with their position like it
okay,
occurs. Then at the end of the string, whatever remains in the stack, we could simply either not print those position or just remove them from the string.
perfect. So this is a very good approach. Why? Because the other approach that Anand was mentioning, it would have almost worked. Only in these cases it will not work. Where say this part is, say this part is valid, but then this part is invalid, kind of thing, right? So you don't know whether you should remove these two or these two, kind of thing, right? So you need to or maybe here it is 3 and here also it is 3, so you have to remove one from here and one from here. So all these cases you don't know, right? You have to remove 3 from here and 1 from here, something like that, right? So instead of storing the characters, we have to maintain the indices somehow, right? So I think the later solution that Narayan, I think, mentioned. Yeah. So that makes more sense, where we are storing the indexes. So do we need to store the characters along with the indexes?
Yes, sir.
Why do we need to store the characters?
So we could know if the character is a opening, like the previous character was a opening or closing. Oh, sorry. 8.
Ideally, you don't need to keep anything in the stack except for the position of the open brackets. So I just need to consider the position of the open brackets. Why? Say if I initially itself, if I got a closing bracket, okay, or say I initially got a one opening bracket and one closing bracket and then one closing bracket. Okay, so whenever I get a closing bracket and no opening bracket in the stack, I know that that is unbalanced. That has to be removed, right? That is imbalanced. So whenever there is a closing bracket, so I can write the rules actually.
Yes, sir, I get it.
Yeah, so whenever we have a closing bracket, encounter a closing bracket without any opening bracket in stack, that means stack is empty, then you know that that closing bracket has to be removed, right? So you can maintain the index, you can add it to your list somewhere, to remove list, kind of thing. You add it to your remove list. Okay, but yeah, but if you find a opening bracket, if you find an opening bracket, then you add the index, because your stack just needs to maintain the opening bracket things, because you don't need to remove at any point of time the characters A, B, D, all these things you never want to remove, right? You never need to remove, so they will not go into the stack. Closing bracket you don't need to put in the stack. Based on the previous problem that we solved, you check with the top of the stack and you remove the opening bracket, not that you push the closing bracket, right? So you remove the opening bracket, so all you can just have is the indexes of the opening brackets only. Okay, so you can have that, and at the end, as you mentioned, the stack will have just the indices which are imbalanced, right? So those also can go into your remove list, and so you can pop everything from the stack and put it in the remove list, and so again you can make another pass, and whatever are there in your remove list, you don't add them to the final string, right? So you can use a string builder kind of thing to, and not add it in the final string. So how the code will look like ideally, let me just open. So the code will look something like this. I'll just try to remove it. So say I have this function. So my Sublime screen is visible, right? My Notepad screen.
Yes, sir.
Yes, sir. Yes.
Okay. So we have, say, we have a string. And we want to, so what do we want to do? We obviously, firstly, we create a string builder, or we can create it later. So we can use a stack. We can create a stack with the characters, sorry, with the integers, because we are maintaining just the positions, right? So we are maintaining the positions. Just save it. Oh, I messed it up. Give me 1 second. I just wanted to save it because of the Java syntax thing. Yeah. So we create a new stack and then we'll iterate over the string. So we iterate over the string, and what we can do is we can check if the element dot char I. So if this is equal to an open bracket, then only we push, right? So if this is an open bracket, then only we'll try to push it. So we will add I, will push the index. Otherwise we'll do two things. So we'll check, so otherwise there can be two things. So it can be a closing bracket, or it can be anything like a normal character, right? So say if it's a closing bracket, then we can just make that check. So if it is a closing bracket, we can make that check. We can say that for a closing bracket, we have two things. One is if the stack is empty, or if it is not empty, right? So if the stack is not empty, then what do we do? We can directly use is empty. No, I think we can directly use empty. I don't remember the syntax completely, but mostly it is empty. Then we can just pop the latest number, right? That means the latest part, the part is valid. So I pop it up. So I'm done. Otherwise, what I do is I know that this element, this closing bracket has to be later removed from the string, right? So I have to later remove it. So I can mark it. So I can have a remove array. So I can have a remove array list kind of thing, where I can add the indexes, what I need to remove later, right? So I do this, and now at the end, my stack, all the processing is done. So once all the processing is done, what I can do is I'm not looking at returning the final size. I'm figuring out the string that remains, right? The string that is valid. So I'll just go through the stack. I'll go through the stack, and I can just I'll add it to the remove. Actually, let's not call it remove. Let's call it to be removed indices kind of thing, right? So let's call it to be removed indices, and here we will add the element. Okay, so this is how now the stack is empty. We are done. So we know which elements have to be removed. So finally we can create a string builder. So we can create a string builder, something like this, and then we can build the string itself, right? So you can either pass str itself to it, and then you can write a for loop to like just go over this array and remove i's. So string builder gives you a functionality to remove the characters. So you can directly remove the characters at these positions, right? The to be removed indices. So I'm not writing that part. So iterate over and remove those indices from SP, right? So you do this and you return the string, right? So this looks like a more or less a decent approach for solving the problem, right? So questions. So the alphabets don't need to be pushed because they are non-consequential. Counter, just having a counter won't matter because you might have multiple groups, multiple chunks of brackets, right? So what will be the time and space complexity of this solution?
Open.
It will be order of n only, right? In the worst case. Makes sense. So this is a very, very interesting problem to solve. It was recently asked multiple times in Meta screening interviews, Facebook screening interviews, and this is a very, very intuitive problem. If you know the first problem, the parentheses one, that most of us know, but this is not, this is often neglected. But this is like almost a very similar solution using a stack. But this needs a bit of common sense, needs a bit of thought before you code it up, right? So the only trick is to store the indices instead of the values of the opening brackets. And ideally, you don't need to store any other thing than the opening brackets. So you don't need to store the alphabets, the letters, you don't need to store the closing brackets, anything, right? So that's the good part. Okay. Questions, concerns, any other questions? Nothing else. So let's discuss another problem then. Okay. So the third problem that we'll be discussing is a bit different again. So now we have say temperatures recorded for a particular location. Okay, daily temperatures for a particular location, and we have to figure out for each day after how many days was a hotter temperature recorded. Okay, after each day, for each day after how many days a hotter temperature was recorded. So for example, so you have the temperature recorded of a particular location, say you have 20. Okay, so for so this is your input, this is your input temperatures array, right? So your output should be after how many days was a hotter temperature recorded. Okay, so the output will also be an array. So for this day, after how many days was the hotter temperature recorded?
0.
1 day after the first day, after 1 day, right? Not 0, so 1 day. For this, 2, 3, after 3 days. For 24, after 2 days. For 23, after 1 day. For 28, after 1 day. For 30, there was no hotter temperature recorded. For 29, there was no hotter temperature recorded. For 22, after 1 day. For 23, there was no hotter temperature recorded. Okay, so this will be your output. So for 25, it will be 3, that is 28. For 24, it will be 2. For 23, it will be 1. For 28, it will be 1. For 30, it will be nothing, 29, nothing. And then 22 again, it will be 23. Okay, so how do you solve this problem? So you have to, your input is an array, you have to return an array as an output.
Sir, for 24 it is 3, na sir?
For 24, it is 28, right? The hotter temperature recorded, it will be 28. So 2 days.
Number of days we are counting.
Yes. After how many days was the hotter temperature recorded? So basically the difference in indices, if you want to think like that, right? Because day 0 is the first index, day 1 is the second index, day 2 is the third index. These are daily temperatures. Okay. So with the hotter, you have to figure out after how many days a hotter temperature was recorded. Okay, so I have two solutions with me, one from Dhruti, one from Jyoti Krishna. Both are order n square solutions. So one loop going from I to n, so I going from 1 to n and j going from I plus 1 to n. Whenever you see a higher temperature at j than I, you know that, okay, I found the next higher temperature, so I break. So, and I add that to my final array. So very good solution. Dhruti, now can we optimize it a bit? So whenever we think of order n square solutions, uh, they're generally brute force. So can we optimize it a bit? Okay. Shweta has a good approach. I'll give Shweta, till you think of the approach, I'll give 5 more minutes to everyone. If you can think of an optimization, then we'll discuss Shweta's approach.
So, um,
Yeah, go ahead.
sir, we can copy the given array into another array
Mm-hmm.
and then sort that array in increasing order,
Okay.
and then we'll start from the first, that is 20, in the sorted array, and then we'll check the next biggest number, that is 24 or 23.
Mm-hmm.
From that, from the given array, the temperature array, and then we will subtract the indexes of both to
But
get the difference.
for 20, the next higher is not 23, right? It is 25. So
Yes.
the moment you sort it, all the indices, and I understand you are keeping a copy, but 20's next higher is not 23 in this case,
Yes, sir.
right? Yeah, so this won't solve the problem. And anyway, yeah, sorting won't solve the problem. So n log n is out of the picture because you have to maintain the order somehow. You have to know the difference in indexes somehow. So n square and n log n out of the picture. Now let's think of an order n solution. We'll try to think. So we'll have 3 more minutes for the thinking part. So I have 2 approaches from Shweta and Putul. We'll discuss either one. We'll discuss Shweta's approach. Okay. General consensus is we can traverse from the end, but that won't solve the problem essentially. So if you see this problem, 23, you know, okay, you find 22, but now you say that, okay, only one difference. The moment you find 29, okay, you minus 1, 30 minus 1.
Like,
The moment you find 28, yeah, go ahead.
sir, we can traverse from the end and keep the track of the maximum we have seen.
Okay.
So like here 23, there is no next element. So we can just simply put -1. Then for the 22, we have seen 23. So we could subtract the position for it,
Okay.
push onto the stack. For 29, we have seen last seen maximum was 23. So there is no maximum ahead of that. Like similarly, and when we reach to here, this 23, after 23, 28, 30, we have the position of maximum element and the element we have seen. We could traverse from here 23 to 30 and see if there is another temperature recorded which was above 23, and if it is encountered, we can minus the position and break.
So the moment you are traversing it multiple times in this region, you are breaking the order in. So because you are coming like this, then you are traversing in this part again, right?
Yes.
So for each value, you can traverse from some paths somewhere, depending on the array, right? And in the worst case, it will again be n square. If I give you an array, something like that, right? So not necessarily will it be order n or truly a single pass kind of a solution. So Shweta, do you want to talk about your approach? Because you were the first to come up with it. So I don't. Okay. Okay, Shweta is on mute. Putul, you want to discuss about the approach that you mentioned?
Yes, sir. So we can use stack and we can keep track of the maximum element. So first we can push 23 and again then if encounter 22. So 23 is the greater than 22. So we can give 1 to this.
Okay. Then
Then if we are at 29, so 29 is greater than 23. So we can pop out from the stack
okay.
and we can push 29.
Okay.
And stack is empty, so we can for 29 the answer is -1. For 30 also, 30 is greater than 29, so you can pop out from the stack and push 30.
Okay.
Again, for 28, 30 is greater than 28, so we don't need to push 28 in the stack. We can keep the answer 1 for 28.
Okay.
Again, for 23 also, 23 is less than 28, so okay, or we can push 28, 30 then 28. Okay. Then for 23, 28 is greater, so we can keep answer 1 and push 23 in the stack. Now for 24 also, we can pop 23 and push 24 into the stack. Answer is 2 for this. And for 25, we can pop 24 and push 25. And for 20, push 20 into the stack.
Okay.
Yeah.
The burning question now, how do you find the indexes? How do you find the for -1? So it's simple. So you said if the stack is empty, I say -1 because yes, on the right hand side there is no greater element, which is evident.
Yes, sir.
For 23, how do you know that distance between 23 and 28 is only 1? Or distance between, say, if this was say 21 instead of 28, how do you know that distance between 23 and 30 is 2? That is the part you missed. So how do you handle that part?
So number of push and pop operation will count that as.
You
So
don't have the
instead
number
of
of push and
value-
pop operations. You are iterating
Yeah.
over only once.
But if the list is in ascending order, we have to push
we
basically
can-
all of the
we
elements
can
again.
keep track
Okay,
of
wait.
pop
Putul,
operation.
yeah, go ahead. Yeah.
So we can keep track of pop operation. Like if we are popping one element from the stack, then answer is +1, like 2. If we are popping 2 elements from the stack, then answer is 3. And if we are not popping any element from the stack, then answer is 1.
Okay. So you are saying that
Like for 28. Like
yeah.
for 28.
So
we are
at
not popping
28 we
anything
have
from-
just 30,
Yeah, 30. And we are not popping anything from the stack.
right?
So the answer is 1.
The answer is 1. Okay. Say if it was 21, then your answer would have been also been 1, right?
Yes, sir. Yes,
Now 23 comes. What do you do?
Now 22, we are popping one element from the stack, 21. And +1. So answer is 2 for 23.
Okay.
Sir, I think we push only when the number is less than the.
No, the push
encountered.
part is fine. The push part, Putul has already explained how the stack will work. I don't have any problems with that. That is working perfectly fine. At least it is a
The
monotonically
number of
increasing stack.
pop operation plus 1 is the answer.
Haha.
The number of pop operation plus 1 is the answer for like indexes.
Number of pop operations plus 1.
Yes,
Okay,
sir.
so if you have 23, 21, 22, and 25, then
Yeah.
or you have, yeah, so you initially you had 25, then you
And
have
for 25
22.
it's minus 1.
So because no pop operations, so it answer is 1 for 22. Yeah, for this it is minus 1. For 21, again no pop operations, so your answer is 1.
Yeah.
Then 23 comes in,
Then 2 pop operation.
you remove 1, you remove 2,
21 and 2. Yeah.
so your answer should
The
be
answer is
3.
3. Yes, sir.
Okay. I'm just trying to break the logic. I'm not getting a right use case. So, okay. So, looks good. I need to like, write it out and think about it. But yeah, now let's take it. This is a good approach. Yeah, I think Shivam has a better solution. Ideally, we should think of storing the indexes also. So Shivam had come up with a different approach also initially, reading the array from right to left, but that will not work. I wanted to discuss that, but I think we don't need to because all of you are on board with a stack-based solution. We need to somehow maintain the least or most recent largest element, right? We need to maintain the most recent largest element somehow, right? And if we have to figure that out, instead of the complex push pop operation that Putul mentioned, better to have the indexes along with the numbers, right? If you store the indexes along with the numbers, the difference between the indexes paint a more straightforward picture than the numbers themselves, right? And if that is the case, then we can directly solve the problem, right, with using a stack. So let's try to solve it using a stack. So I'll just explain what I think Shweta was also mentioning a similar thing. We can do it from left to right also. Okay, so let's do it actually from can we do it from left to right? Yeah, we can do it from left to right actually. Or okay, let's use right to left only because that we are already doing. So I'll just write the array again, just reducing the font size a bit. Let me know if anyone has problem seeing the font, right? Then I'll increase it after I just copy it from above. So we have 20, then 25, 24, 23, 28, 30. So ideally, Putul, why I mentioned that don't use the 2 push 1 pop, that whatever the complex formula we're coming up with, right? 2 push, number of push plus 1, because there is no definite logic to it, right? We are just trying to hook onto a pattern, right? The problem with hooking onto a pattern is that when we are trying to solve the problem, it might seem obvious. There might be corner cases where it might fail that we are not thinking of, right? So that's why when you see a pattern, try to think of what is the actual logic that can be there. Don't just try to hook on the pattern. Okay. Why do we need to use a stack? First of all, we need to use a stack because at each point, I just need to find the next greater element. And from here, if I know the next greater element is, I know how many, like where the next greater, what is the next greater element to 30. For any number greater than 30, I know what is that element only should be the next greater element, right? So, or say if I know that here 30 is here, for any numbers which is less than 30, I know that this will be the bound, right? This will be the boundary. The next greater cannot be after this, right? Because all these numbers are smaller than 30. They can be before, like for 20, it is 25, but they cannot be after 30. 30 will be the maximum possible right bound, right? So what we will be trying to build is a monotonic stack. So the concept that we'll use here is a monotonic stack, which means that the stack will have some order in which we will push the data. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8. right? And so when we push elements into the stack, we say 23 at 8 pushed. Actually, I don't need to push the numbers also. I just push the indexes, because ARR of that index will directly give me that number in order one time, right? So I just push 8. Then 22 comes. I check, okay, is 22 greater than ARR of 8? No. So it has to be a monotonic stack. So I know that 8 minus 7 will be the answer for this. So this answer will be 1. And I know that 22 is lesser than 23. So I push 7 here. Right? Then for 29, I check, okay, is it bigger than ARR 7? Yes. I remove, I pop ARR 7. Right? Why I pop it? Because I know that the number, if 29 a bigger number I found, then I will never care about this number. Because any number which is smaller than 29 on this left hand side will have a bound of 29. If any number is there which are bigger than 29, they will anyway have a bound of -1, because there is no other element to the right of 29 which is bigger than that. Right? So I don't care about 22 anymore. So I remove it from the stack. Then I check whether current number is greater than ARR 8. Yes. Again, I remove it from the stack. I push 6. And for this, what will be the answer? Because nothing is in the stack, none of the elements were valid, none of the elements generated a valid output, so I give -1. 30 comes in. I check with ARR 6. Is 30 bigger? Yes. I can't do anything. I put 5. Right? I put the 5 in my stack. It is the index, and I put -1. 28 comes in now. The moment 28 comes in, I check with whatever on top I have on the stack. ARR 5, 30. Yes, 28 is smaller than 30. So what will be the output? 5 minus 4. That is 1. So 1 goes here, and 28 is pushed on the stack. So we have here 4. 28 means index of 28. 23 comes. I know that yes, 23 is less than 28, right? On the top of the stack. So 4 minus 3, again 1. And I push this. Then 24 comes. I know that it is greater than this. So I remove this. Then I see it is greater than 28. No. So I push 2 here. What will be the answer? 4 minus 2. The top of the stack minus the current value. Then I get 25. Compare with 24. I remove 2. Compare with 28. So it is correct. So I put 1. 4 minus 1. The answer is 3. And finally 20 comes. For 20, I see that the top of the stack is good enough. So I put 0 here. And I write 1 minus 0. That is 1. So the output is this line. Okay. So just combining the two solutions, one given by Putul with maintaining the stack, the other by Shivam, that instead of storing the values, we just need to store the indices, because the moment you have an array, if you have the index, you can get the value in order one time, right? So you can just store the indices, and the difference between the indices is your answer. You don't need to keep track of the number of pops. You don't need to worry about the number of push, because that is not a definitive answer. You don't have a logic for that. It is happening for many cases, but there is no sound logic for that. Okay. So this is a good solution. So what will be the space and time complexity for this?
Order of n.
And
Again, both will be order of n, right? Okay. So we have looked at two solutions ideally. We have not looked at the first solution, which was an order of n square approach, the brute force approach, that I think initially Dhruti had mentioned, few of you had mentioned that you check with 20. For 20, you check from 25 to 23, whichever is bigger. For 25, again, you check from 24 to the last. From 23, again, you check from 28 to the last, right? So that is the brute force approach. So brute force approach would have been an n square in time. Time complexity always gets more preference than space complexity. So even though this had lesser space complexity, we still increase the space, but we reduce the time. Okay, so this is a better approach now. Right? Why does space complexity get lower priority? Because space is easier to get. Time, if you have huge amount of data, you can distribute the data and you can still compromise on space. You can use more space. But time once lost, the real-time nature of functions, the speed of the application, these all reduce, right? So time is a more valuable asset. Follow-up question to this, and probably the last question of the day. So can we do it without a stack? Now we'll do one more question depending on how much time is left after this discussion. So can we do it even without using a stack now? Because the order in space is there. So can I reduce that altogether, remove that altogether, and solve the problem in order in time and order one space? Anyone? Can we solve it without stack? And a constant extra space, meaning the final array that we are creating, we will have only that array. Can we do it with that? Okay. We have one. Can we use another array? You have the final array anyway, Anand. So you have the output array, you can use that. If you have another array, say you have that array itself, right? So what would you do?
If we can have another array, then directly we can run a loop and compare.
How will you compare with one loop? Will it be order n solution in that time, in that case? If you have just 1 second. Yeah, so you said if you want to have, say, another array altogether. So now you have two arrays. So I made a copy of this array itself. What would you do now? Whatever you do, mostly it will be order n square, right? For 20, you will be still checking in the next all the elements of the second array. or for 25 you will check for 24, 23 in the secondary somehow. So that's not a good solution, but that's not an optimal solution. Yeah. So anyone else? I'll give you 1 more minute. So why I want all of you to think of a solution is otherwise the class becomes completely a dictation kind of thing. And if you don't think of the problems when you are looking at it for the first time, then later when you look at it, you know the solution, right? So your thinking capabilities doesn't get generated. So that's why I often like give 1-2 more minutes to think, because that is as important as knowing the solution. Later you see a problem similar to it, you will be able to apply this approach there. But if you don't think now, you will never be able to generate that capability. That's why. So anyone else, or if you have any hunch also, we can discuss that, and we can try to see whether it is working or not. Right? That also helps. Nobody? Okay, chalo, let's discuss the solution. So say we have an array. I'll take a smaller array in this case, okay? And then we can always replicate it to the bigger one. So say I have this array for now. I have, say I have 20, I have 16, I have 8, 9, 10, 25. Okay, so we just compare with the next elements first. Okay, we compare with the next elements first. So for 25, I know that there is no answer, right? You don't have an answer. So you first, for now, you keep 0 for now. So output has to be -1. We'll come to that. For 10, you know that the next element itself is bigger. So you say 1, right? For 9, you know that the next element is bigger. You put 1. For 8, you know the next element is bigger. You put 1. For 16, you know that the next element is not bigger, right? So you find out after how many elements you find the next element, the next bigger element. So 1, 2, 3, 4. Till now, everyone is with me. Till now, it looks like it will become an order n square approach, right? Because for 20, again, we will go over the loop and go till 25.
Yes, sir.
Right?
Yes,
But
sir.
yeah, but for 20, can you intelligently tell that the next greater number has to be 25 instead of going over all the elements?
Sir, if we compare 20 and 16,
Yes.
if 16 is less, of course that 8, 9, and 10 will be less, sir, because 16 index is 4.
Correct. 16's index is 4. So that means
not
that
index actually, that value is
correct,
4.
at least after 4 elements, there is an element which is bigger than 16.
Yes, sir.
You don't know whether it is 25, you don't know whether
Yes,
it is 17, you don't know whether it is 18, you don't know whether it is 20 itself, but you know that after 4 elements from 16, there is an element which is greater than 16. Just
yes,
that.
sir.
So at 20, what you do is you add 1 plus 4 plus whatever the value, plus you decide based on this value.
Yes, sir. Again, 0.
Yeah. If this value was 25, that means plus 0. Yes. If this value itself was, say, 2, right? And say this value is, instead of 25, it is, say, 18.
So make a bigger array, I think.
Then you have 9, then you have 18, then you have 17, and then you have 21. Then when you have jumped here, you know that this element is 18, and after two elements, there is an element which is greater than 18, right? So you jump again 2 steps. So 1 plus 4 plus 2 plus here, you come here. You found 21, you are lucky, so you stop. So your answer is 7. But if you found 19, then again you would have jumped, right? And if this array would have ended at 19, then you know that there is no greater value, so you make it -1 itself, or you mark it as 0 itself, and later in the next pass you can make all the zeros as -1. Okay, so in this way what we are doing is we are iterating over this part only twice, once the first time and once for 16 I'm doing 8, 9, 10, 18. But when I'm seeing 20, I'm not doing 16, 8, 9, 10, 18. I'm just doing 20, 16, 18, 21. I'm jumping over them, right? So how many times in the worst case are we iterating over the array?
N times, I think, sir. No, sir.
We are not
N,
iterating over the array n times. One time we are doing this 1, 1, 1 like this. For 16 we are doing 8, 9, 10, 18. That is one pass. And then for 20 I am directly getting 16, directly jumping here, directly coming here. For if there was
log n.
another number here, say there was another number here 23, I would have jumped here, then I would have directly jumped to the end. I would have directly jumped to the end, right? Or because for 20 I know that it is 0, that means there is no number to the right of 20 which is greater than 20. That means for 23 also the answer has to be 0. If I knew that for 20 the answer is say 8, that means somewhere some number is there which is greater than 20, say 22, I would have jumped 8 steps, I would have come here and checked with 23. If I found that again after 2 numbers something is greater than 23, say 24 I had here, then I would directly jump 2 steps, right? So in the worst case, how many number of times is each number getting visited?
Log n times, I think.
Why log n times?
If
This is
not
just
n.
guesswork. There
Yes,
is
sir.
nothing related to log here at all. For 16 I can see till I have to go till 18, that is one time, but for 20 I'm jumping directly from 20 to 18. For 23 I'm not even visiting 18, from 23 I'm going to 20, then to 21, so that space is getting bigger and bigger, right? Small space, then it becomes bigger, then the jumps become bigger, then the jumps become bigger, right? But each element is being visited a constant number of times.
So 2, maximum 2.
Exactly, maximum
Yes, sir.
2 times. So each element is being visited maximum 2 times. So 8, 9, 10 is there, you are visiting once. From 16, right? From once you are visiting normally 8, 9, 10, 1, 1, 1, you are giving the answer. Then from 16 you are visiting one more time till you get 18. Done. 8, 9, 10 will never be visited. Then 20, 16 gets visited once again, the second time. Then directly 18, 2 times. Then 23, 20, 2 times, and then again the end, whatever is there. Right, so you will at max you will visit all the elements or most of the elements only 2 times. So your order of complexity will be order of n only, right? Order of 2n is order of n, and space complexity in this case will be order of 1. You are not using any extra space apart from the array that you have to return, right? So you are not using a stack, you are not using a map, so no other complex data structure to solve the problem. So this is a very intuitive solution. Often problems where we try to use a stack, even the stack is not required, right? And these cause issues when you are actually appearing from programming contests, not for interviews, but for programming contests, where depends on your program complexity, your ranks are determined, not just the correctness of the code. Right, so for very big test cases your stack code might fail because that much space was not available in the memory, right? So those types of issues generally happen. So we will quickly write the code for the second approach, right, so that we can formalize it. So we'll have a integer array, we'll have daily, we'll call it next higher temperature, right? Let's call it ARR for now. Okay, and what we do is the base case, the array is null, obviously you return some empty or something null kind of thing or an exception. So we are not going into that. So we are finding the length because we have to create a new array also, right? So we create a result array. Okay, and then what we do is if there is only one element, you return the result directly, right? Because answer will be 0 for the first element. The answer will be 0 or -1. If it is -1, you just make result 0, result I equal to -1, result 0 equal to -1 and return. So I'm not going into those corner cases. So just the main case that I'm thinking. So I'll just start from the end. I'll not start from the last element, because for the last element the answer has to be 0, right? If you remember, we are putting 0, so I'll start from length -2 and I'll go till the beginning. Okay, what I'll do is, I know k equal to I plus 1, that means the next character, next temperature, and then I'll just check while arr I, and this is where the trick happens. So if this is greater equal the kth element, the one that we are looking at, right? If this is greater than that, and obviously the other condition that we'll put is if that value itself is not equal to 0, that means there is some greater element ahead of it. We have to jump, we have to make those jumps, right? So we will just check. If this is not equal to 0, then the jump that we will make, so jump will be equal to this. So we'll make those many elements jump again, and then again I'll be checking for in the while loop. Okay, so and at the end, if I find that this the last element that I have found, right, if that is actually less than the current element, current k, if I found that the element where I stopped finally, right, the element that I have stopped finally, if it is less than if it is greater than I, then I return the difference in the indexes. So I return the difference in the indexes, right? So this looks more or less correct.
That will be result or res?
Yeah, make it result res. Yeah. Okay. Yeah, correct. And this is done, and at the end I'll return result. So obviously at the end, if you want to make it -1, I have not handled that case. I have not done the -1 part. So you can just iterate over the array. Wherever there are 0, you can make that -1. That means there are no higher temperatures to the right. Something like this. Okay. So this will be like a order 1 in space, order n in time kind of a solution without a stack. Right? Why do we start from len -2? Because the last element we know that it has to be 0. Rest of that has to be 0. So we don't care about that. Right? We only care about the other elements. Okay. So this is a very good solution. Can anyone tell why we don't need to check for k within the bounds here? Like I can easily make a check here, something like that, k less than arr dot length or len. I have already calculated. So why do I don't need this? Why do I not need this check, k less than n kind of a check?
Because k equals to I plus 1 and I is already length -2, sir.
Yes, so you always know that k has to be valid on the right hand side, right? So k has to be valid because you are starting from the right, so k has to be a valid number. It will be within the bounds, otherwise it will be 0 and this whole while loop will anyway break. So you don't need to have this check at all, right? So these are small things that you need to think of while you are coding things up. Okay.
Sir, if length equals to 1, we are returning the whole array.
No, we are returning the rest. So if length is 1, then we are just returning an empty array with something 0. Or if you want to do this kind of a thing, you can just do res0 equal to -1 and return. Whole array, only that one element with 0 or -1. So earlier I was doing with 0, so I returned res. If you write this, the comment part, if you try to implement, then you have to handle that also here. There is only one element, right? So there is nothing to the right of it. You have nothing to process. There is no next greater temperature at all. Okay, so these are basically your corner cases that you need to think of. Okay. So yeah, we looked at one particular data structure called the stack today. Simple. Applications not that simple. Lot of other problems are there. Take a look. We will discuss more on stack bit later in the course, right? We'll come back to it. So tomorrow we'll discuss a bit different type of problems, not on queues. So people take stacks and queues together. So have that intuition and try to solve all problems tomorrow with queues. We'll take a completely different type of algorithms tomorrow. Okay. Yeah, so from this week we'll try to have regular classes. So I had this is November, December, Jan, so we have a lot of marriages this time. So last weekend I was not in Hyderabad, was not available. So but after this I am available on all the weekdays, like all the next weekend. So there will be regular classes unless there is something in the college, right? So yeah, that's it from today. Any other questions you have before we wrap? Anything? Okay, I don't see any other questions. Cool. We'll wrap then. We'll meet tomorrow. Try to solve these 3 problems at least, right? And try to code them up, or try to look at the recording, try to code them up, and try to solve the problems. And yeah, let's use the WhatsApp group a bit more frequently in terms of queries and doubts. Do put it in the group directly. Okay. Thank you. Bye-bye. Good night.
Thank you, sir.
Yeah. Bye.